Is actually good after morning because exactly 12 o'clock is there. So welcome to this session. My name is Anoop and you are on Unacademy NEET Elixir channel. Here today on Sunday we are going to have a very beautiful session, and this is what we know as the marathon session. Many of the students have asked that, sir, what exactly is going to happen of the surface chemistry chapter, because surface chemistry chapter has actually been removed from the NCERT books. So maybe it's not going to be in the NEET as well, but if it is in the NEET as well, then we need to have a particular session in which we have completed the surface chemistry completely, thoroughly. So today we are going to have a marathon session of surface chemistry, and in this particular session we are going to start and finish with surface chemistry. I have kept 3 hours for this particular session. If it is enough, then in that case we are going to complete this particular chapter in one go. If it is not, we are going to have another session today in the evening itself. So today would be the last breath of the chapter called surface chemistry. So all those who have watched, those who have joined the session, please share it with your friends so that they also can join. It is good, it's much better to join in a live class than looking at the recordings. So let's get along with it. Purnesh, you are here. You had asked for this particular chapter. Parvit, solution chapter is going on in a different stream. We can have multiple streams going on at the same time, isn't it? We are going to finish off the solution chapter, no problems with that. But now at this moment we are talking about the surface chemistry chapter. Is that clear? Is that okay? So let's begin over with the surface chemistry chapter. We are going to talk about the surface. Before that, we are going to talk about myself. My name is Anoop VASHISHTHA. Yeah. Yep. So where is the remote? Here it is. So could we shift it like this? Is it working? No. It's not working. Fine, no problems. So my name is Anoop VASHISHTHA and I am an MSc in chemistry from University of Delhi. I have an experience which is around 1.5 times of your age, even more than that. I have an experience of more than 26 years. I started teaching in 1995 and then I started teaching the classes of IIT and medicals in 1997 while doing my post-graduation. So lakhs of students have been taught by me. I have lost the count, but let's see. So that's what we have about me, and today these are the topics that we are going to start. Okay. No, this is not working. Okay. So this is what we are going to do. We are going to talk about adsorption. We are going to talk about types of adsorption. We are going to talk about Freundlich adsorption, isotherm, the colloids, the classification of colloids, preparation of colloids, properties of colloids, and even the catalysts. So that's what we are going to do in this particular chapter. So let's get along with surface chemistry. What exactly surface chemistry deals with? Now, when we talk about the surface chemistry, it deals with all the phenomena taking place on the surface. Now comes what exactly is so special about the surface. So is it possible to understand the whole chapter in one go? Of course, Purnesh, it is very much possible to understand the whole chapter in one go, and moreover, this chapter is going to be recorded. The entire session is recorded. If you feel like that you are not able to follow it in one go, then in that case you can always pause it, understand it thoroughly, and then you can go along with it at a certain suitable time. So don't worry about it. And this chapter is not a difficult one. It doesn't involve too many calculation. It doesn't involve too much high concepts. It is more of the information. And if you can watch a 3-hour movie with full concentration, what's the big deal about 3-hour session? So you'll be able to understand it. Yes, Amit, I have been many places and now I am in Unacademy NEET Elixir, and this is an English medium channel, and I hope you are able to understand my English thoroughly. Well, none of you have ever complained about me talking about in English, so I believe you are able to follow my English thoroughly. So has everybody liked it? Yep, Ananya Sarkar is there, Purnesh is there, Pravit, Radhika. So all you are here. Yes, it is one shot. So now when we talk about the surface, there is something about the surface. Let us say we have the particles which are joined together. The particles are joined together like this. Now when the particles are joined together, obviously this is, theoretically we say this is an infinite array of particles, this is an infinite arrangement of particles, but actually infinity does not exist. There has to be some limit to the particles. There has to be one particle that is at the edge, there is some particle on the corner, there is some particle on the surface. When we talk about this particular point, this is what we can call as the corner. This is what we can call as the edge. And then if you talk about in 2 dimensions, it is going to become a surface. Now as you can very well see, there are different kind of particles. There is a particle within the bulk, that is, this particle is in the bulk. Bulk means that it is surrounded by the particles on all sides. It is right embedded inside the solid. So this is what we have on the bulk. Okay. So this is on the bulk, and then we have the particle on the corner, surface and the edge. One thing is absolutely clear, that the particle on the corner, surface or the edge is not surrounded by the particles on all sides. There are some vacancies, some valencies which are not yet satisfied. It has some vacant spaces. Ananya, my being here itself is motivation enough. Okay, if you feel like that you need to be motivated in the initiation of a session, fine enough. We can begin over with the motivational quotes. Karan, you are studying in Delhi, I am in Delhi. I am going very slow, I am going to tell you everything about it. Yes, states of matter also is going to take place, solution chapter is also going to take place, and surface chemistry is going to be completed today itself. Is that clear? Perhaps if possible we are going to have the solution chapter also as a marathon session, so that we can finish it off thoroughly, nicely and quickly, isn't it? Your school examination also are going to go on, and in school you would have finished off with the solution chapter already, and the states of matter chapter is not there in 11th, so I believe that needs to be finished off quickly enough. Okay, so we are going to increase the duration of each session. So here it goes into the bulk. Now when we talk about the surface, edge and the corner, these particles have the free valencies. That is, they still have the combining capacity which is left. I believe you have understood that at the end of the stream, let us say there are certain students who have joined hands with each other, then the person at the terminal of the chain, they have one hand free, which we can term as they have certain free valencies or vacancies. Now these free valencies are termed as dangling valencies. Now due to these dangling valencies, the surface, corner and the edge particles, they are more reactive as compared to the bulk particles, and that makes the surface, edge and the corners reactive, and that is why all the reactions initiate from the surface, corners and edges. Corners are absolutely the most reactive, isn't it? Any confusions with that? Clear? So whoever is not liked, quickly like it. Nahi Ananya, you don't need to study any other chapter for understanding this particular chapter. This chapter is easy enough. Just go thoroughly with me. And what I have told you, it is not something about the solid state, it is something about the common sense. I hope you don't need to study solid state to develop the common sense, isn't it? Am I clear about it? Clear? So, just rely on your common sense and you will understand everything. So here what we find is it deals with a phenomenon that occurs at the surfaces or the interfaces. It is represented by separating the bulk phases. Okay. So that's what we have as the phenomenon. This is what we call as the surface, which is differentiated from the bulk. As far as surface phenomenon goes, we have three phenomena. One is what we call as surface catalysis, we have the adsorption, and what we have as the colloids. We have to get along with something called adsorption. Now, there is a word called adsorption and there is another word called absorption. Ab is to drink. When you drink something, when you drink water, the water goes into your bulk and it spreads inside your body. So, ab is when a substance drinks a particular substance and it spreads throughout the bulk. That is what we call ab. Absorption is to, again, to take inside. So, it is absorption. Absorption would mean that the substance spreads evenly throughout the bulk. On the other hand, when we talk about the word add is just to attach without getting inside. So, add is to attach on the surface. In case of adsorption, the concentration of the substance is highest on the surface and inside the bulk it drastically decreases, although we can even say that it is not even reaching inside the surface. So, that is what we have as adsorption. Adsorption is a surface phenomenon since it remains on the surface. You can compare it like taking a bath and drinking water. When you drink the water, it spreads inside your body, but when you take bath, it sticks onto the surface only. So, taking a bath is something like adsorption, while drinking the water is absorption. Am I clear with that? Ananya, both can take place simultaneously, because if we take a bath, then in that case your skin can even absorb a little amount of water. It gets swelled. You understand that? So, there is a little bit of osmosis, there is a little bit of water moving inside your body so that it wrinkles, the skin wrinkles and all. That does happen, but majority of it is adsorption. It remains on the surface. It does not go everything inside. Yes, Akash, it collects onto the surface but does not penetrate. So, then as we go inside the bulk, the reactivity of particle decreases. Yes, Priyanshu, the reactivity of the particle does decrease, but to move inside the surface, you have to scratch it and then it is going to become the surface. If you break a solid substance, then in that case, new surface is exposed and that newly exposed surface is enough reactive. That is why we find that once we powder a substance, then in that case, its reactivity drastically increases. So, that's what we have as add and ab. Please understand that apart from being at the surface phenomenon and the bulk phenomenon, there is no difference between adsorption and absorption. Many a times people say that adsorption involves more energy change, but absorption also involves the same kind of energy change. So, don't get confused with the many other differences. The add and the absorption, they differ only in the phenomenon that one is surface and one is bulk. Now, it is accumulation of molecular species at the surface rather than in the bulk of the solid or the liquid, which is called adsorption. Now, when we talk about adsorption, there are two terms, the adsorbate and adsorbent. Adsorbent is the substance on the surface of which adsorption takes place. In this particular chapter, the adsorbent in this case is a solid. We shall be taking a solid adsorbent. Is this clear? In case of adsorbate, when we talk about the adsorbate is a substance which is getting adsorbed. Substance getting adsorbed. Now, the substance which is getting adsorbed in this particular chapter, we are going to talk it about as the gas. Now, please remember, the substance getting adsorbed could be a liquid, it could be a solid, but here for this particular chapter, for our convenience, we are going to consider a gas. So, we have gaseous adsorbate and a solid adsorbent, so that we are talking about the adsorption of a gas on the solid. Now, these adsorbate and adsorbate, they have a different kind of interaction with each other. It's a molecular species or the substance that concentrates or accumulates at the surface, that is what we call as the adsorbate, and the substance which is getting adsorbed, it's the adsorbate, and the substance which is absorbing it, it's the adsorbate. So, this is the adsorbate which is sticking onto the surface of adsorbent. So, this is, and this one is the adsorbate. Adsorbent is a submaterial on the surface of which the adsorption takes place. In our case, it is the solid. So, here we have the adsorbent on the surface of which adsorption is taking place. Iron rod is the adsorbent and water is the adsorbate. Which phenomenon are you talking about? You are talking about the wetting of the iron with water, or you are talking about rusting? If you are talking about rusting, then in that case, yes, it is initiated by adsorption, but it turns into absorption because rust does not remain on the surface, it reaches the bulk of the iron. So, rusting initiates with adsorption, but ultimately it becomes absorption. Now, you need to understand a phenomenon in which adsorption and absorption both take place. It is simply termed as sorption. Sorption is a combination of ad and ab. Clear? Okay. I would sincerely request you to make the notes right in the class, but I am working on a book that I am going to share very soon with you, and this is going to be a dynamic book in which we are going to keep on adding the information on a daily, weekly, monthly basis. As I am going to get any information about any of the chapter, I am going to put that in the book, and I am just working on the phenomenon how we can have a dynamic book, ever changing book. Okay. So, that wetting is more like adsorption, the physical adsorption. Clear? Fine. So, gases like oxygen, hydrogen, carbon monoxide, chlorine, ammonia, sulfur dioxide are taken in a closed vessel containing charcoal. Now, this charcoal is termed as activated. Activated charcoal. Clear? Yes, we are going to talk about physics option and chemistry option as well, and whoever is joined the session, have they liked the session? And have you shared the session with your friends? Because we have only 15 students at this moment on the session. Okay. So, activated charcoal is the substance which is put in the gas mask and every place where the gases need to be adsorbed. Activated charcoal is a normal charcoal powder which has been treated at a very high temperature so as to clean its surface of any adsorbed material initially. So, activated charcoal has a huge free surface on which adsorption can take place. So, that is what we have as activated charcoal, which is being used in to adsorb these various gases. Now, can we reverse the process of adsorption? It all depends which kind of adsorption we have. If we have the physisorption can easily be reverted by increasing the temperature. Physisorption, yes. Chemisorption, And physisorption, when we do it, it is called desorption. Desorption is removal of the adsorbed material from the surface of the adsorbent. It could be because of increase in temperature, or it could be because of change in its chemical nature. Like in catalysis, we are going to discuss how the desorption is taking place. Well, when we talk about palladium, it is not exactly adsorption, it is more like occlusion. The hydrogen actually gets dissolved in palladium so as to react with it. Now, that is a different phenomenon altogether, but in catalysis, yes, it is adsorption on the surface. So, desorption is the process of removing an adsorbed substance, that is adsorbate, from a surface on which it is adsorbed, that is adsorbent. That is called desorption. Now, to talk a little bit more about absorption, absorption is a bulk phenomenon. It is the particles of the gas or liquid gets uniformly distributed throughout the body, which we term as the bulk of the solid. I hope you have the old NCERT also with you. If you have the old NCERT with you, then in that case you can open up the chapter called surface chemistry in the old NCERT. New NCERT does not have the chapter called surface chemistry. You have the old NCERT available on the internet also. You can download it from there. Any application of absorption in real life? Well, there are so many applications of absorption in real life, like let us say we have a cloth getting colored. You colored a cloth, you find that the color sticks onto the surface while water moves inside. The water is absorbed while color is adsorbed. So that is how we can talk about this thing. So there are so many applications. Okay, and we talk about the catalysis. Catalysis is an example. Then we can have like you can have just a chalk piece and you can just put it in ink. When you break it, you will find that the ink has remained on the surface while water is moved inside. That again is an example of ad and ab. A part of the substance is getting adsorbed while the other part is getting absorbed. So both phenomena are taking place at the same time. This is the example. We place the chalk piece in water, the ink, colored water. Then in that case, this chalk piece is going to take in water, and you will find that the chalk piece, water, it is getting surface, it is colored, inside it is not. The surface particles of the adsorbent are not in the same environment as the particle inside the bulk. I have just told you it has dangling valencies. This is the bulk, whereas the surface, it has the dangling valencies. Inside the adsorbent, all the forces acting between the particles are naturally mutually balanced, but on the surface, the energy, this particle C, this has unbalanced energy. And I have already told you the name. The unbalanced or residual forces, they lead to something called the dangling valencies. Okay, you can just keep on asking me on the chat. I will be able to answer all your questions. Okay. Now, these unbalanced forces of attraction are responsible for attracting the adsorbate particles on its surface. The dangling valencies. How many times I should use the word dangling valencies? Clear? Now, when we talk about the thermodynamics of adsorption, one thing we need to understand that when we talk about adsorption, here the gaseous particles are attaching to the surface of the solid. There are a lot many particles which are getting converted to one particle. So one thing is absolutely clear, whenever we talk about adsorption, it is delta S negative. Delta S negative would mean there is a decrease in entropy. Delta G is equal to delta H minus T delta S. Delta H is equal to delta G is equal to delta H minus T delta S. So when we find this delta S is negative, it would mean this particular part becomes positive. So it is quite true that as we keep on increasing the temperature, the T delta S factor is going to increase in magnitude. As that factor of T delta S increases in magnitude, the delta G is going to become less negative with increase in temperature. Am I clear with this particular statement? What if the adsorbent is porous? Adsorbent is always porous, Dr. Akash Patwa. But when we talk about the pores, again that pores inside have the surface. Pores can be considered like caves, gufa. So when we move into those caves, the walls of the caves, they are going to work as the adsorbent material, and again it's going to remain on the surface. The porous adsorbents, they are what we use. We want to have the huge amount of surface area, and that makes charcoal a very good adsorbent, because it is porous. Okay, we can't even call that it goes into the bulk, because bulk would mean that it goes inside those walls of the pores, not just the pores. Is it clear, Akash? I hope you have got the answer clear. Now, so as we increase the temperature, the adsorption would decrease because of the entropy factor. You can always say that adsorption is entropy non-favorable. So the adsorption is entropy non-favorable. Any confusions to anybody? So adsorption involves a decrease in residual forces or the surface energy. Energy is released, so that heat of adsorption is negative. Yani ki adsorption is always exothermic. Well, here I would like to make certain things clear. Adsorption is not necessarily always exothermic. There are certain phenomena in which the adsorption actually becomes endothermic. But those examples are not in your course. The NCERT simply says that adsorption is always exothermic, and since NCERT says adsorption is always exothermic, we are going to consider adsorption to be always exothermic. So if anybody tells you otherwise, you may simply say that I know it may be exothermic or endothermic, but NCERT says it's exothermic, so I am going to consider it exothermic. Is that clear? Sanchita Gayan, you say it is a spontaneous reaction, but don't you think the spontaneity also depends on condition? If I change the condition, a spontaneous reaction may become non-spontaneous, while a non-spontaneous reaction may become spontaneous. So spontaneity is condition dependent. So simply don't say that adsorption is spontaneous. It is going to be spontaneous under a specific set of conditions, something like temperature and pressure. Okay, Gibbs energy is negative, that means it's spontaneous reaction, but Gibbs energy being negative also depends on condition, isn't it? Like when we talk about boiling of water or evaporation of water, then in that case at a temperature less than 100 degrees Celsius under 1 atmospheric pressure, the boiling of water is non-spontaneous, but more than 100 degrees Celsius it becomes a spontaneous reaction. The delta G becomes negative above 100 degrees Celsius while it is positive below 100 degrees Celsius, isn't it? So please remember that delta G is conditional, and one factor on condition is temperature. Okay, I hope I am absolutely clear about it. Okay, it's something like, would you like to drink water? Now, would you like to drink water is a simple question, and its answer could be yes or no or maybe depending on the condition. Clear? In the same manner, we talk about delta G and spontaneity. Hello Munna, good to see you here. Radhika, Sanchita, Munna, Akash, Ananya. Well, good to see you students here, and Tell your friends also about these sessions. Clear? Purnesh is here because this session is specifically because of demand from certain students. Now, adsorption is always exothermic. That is written in NCERT. So, delta H for adsorption is always exothermic, and with the same phenomenon we can say that adsorption is always delta S negative. That is, it's always entropy non-favored. The freedom of the movement of gaseous adsorbate particles is restricted due to adsorption, so entropy decreases. Delta S is less than 0, that is, delta S is negative. So, here we talk about adsorption. Clear? The particles, they stick to the surface, and when they stick to the surface, they decrease the entropy of the system. The free moving particle number has decreased, and as the free moving particle number decreases, the adsorption becomes entropy non-favored. Clear? So, delta G would become negative only when we have a sufficient high amount of delta H being negative. So, here we find that adsorption decreases with increase in temperature. Which one of the following characteristic is associated with adsorption? Just tell me which of these four options would be the correct one. Answer. And whoever is not liked, quickly like the session. Read through it and give me the answer. What happened? Why are you not answering? Is it such a difficult question? Radhika has given me the answer. What about the others? Arpita, Priyanshu. Priyanshu, think again what you are writing. Delta H positive would mean that the reaction is endothermic. Is it endothermic? Ananya, Munna, Ananya, Munna, Priyanshu, think over your answer once again. What are you telling me? Delta H positive would mean endothermic reaction. Endothermic would mean that the temperature actually decreases, it absorbs energy. The answer is actually D. Delta S is negative because entropy decreases. Delta H has to be negative, it has to be an exothermic reaction, and because of the delta H being negative, the delta G becomes negative, and that is how it becomes the spontaneous reaction under the given. D, then endothermic, exothermic. Adsorption is exothermic. Did we not just do it in the reverse slide, previous slide? S is negative, Akash. That's what we already discussed. Were you not looking at the screen? Ananya, Purne, and Ananya, Priyanshu, correct? Okay. So let's talk about the different types of adsorption. In fact, we have only two types of adsorption, physical and chemical adsorption. That's what we are going to talk about here. We have the physical adsorption, which is also termed as physisorption, and then we have chemical adsorption, which is also termed as chemisorption. Now, what exactly is the difference between the two? Physical adsorption is when the accumulation of the gas on the surface of the of a solid occurs on account of weak van der Waals forces. Now, these are the dispersion forces. These are much weaker than the intermolecular or the intramolecular or interatomic forces. So, that is what we have as weak van der Waals forces. Weak van der Waals forces could be the dipole interaction, the weak van der Waals forces. The dipole interaction could be the okay. So, what have we found? That it takes place when we have the weak forces, which could be dipole interaction, which could be the dispersion forces. It could be due to the dispersion forces, or it could be even hydrogen bond. So, these are the phenomena which could be responsible for the physical adsorption taking place on the surface of the solid. Now, these forces do not require any activation energy. They do not need to be activated. Okay. So, here no activation energy is required. Since no activation energy is required, they can easily take place at low temperature. So, here no activation energy needed, no temperature to be increased, it can take place at low temperature. In fact, lower the temperature, better the physical adsorption happens to be. So, physical adsorption actually increases with decrease in temperature and decreases with increase in temperature. Under NCERT line, delta H of adsorption is always negative when a gas is adsorbed. The freedom of movement of its molecule becomes restricted, and that is why delta S also is negative. Ananya, got it? Perfectly clear. NCERT line is absolutely right. No confusions with that. Okay. So, since adsorption negative, the delta S is negative. Got the answer, Ananya? I believe you understand where the mistake was. Okay. So, no activation energy is required as far as the physical adsorption is concerned, and that is why physical adsorption is always increasing with decrease in temperature. Okay. And most important, in case of physical adsorption, once we have a layer of adsorbate on the surface of adsorbent, we can have another layer of adsorbate on the layer of adsorbate itself. So, physical adsorption most often turns out to be multi-layered. The physical adsorption is multi-layered, layer upon layer, and the typical examples of that could be like you are driving on a cold night or in monsoon, and you find that the layer of fog or water appears on the windscreen of the car. Now, it is initially not that foggy, but slowly and slowly over the time it becomes more dense and you are not able to see the road. Now, that becomes multi-layered adsorption, multi-layered physical adsorption. The first layer of water is formed on the surface, and over the water surface more and more of water is formed. Now, please understand, in this case this adsorption is same as condensation. So, that is what we find in the physical adsorption. The physical adsorption phenomenon, we find that the gases which are more easily liquefied are more easily adsorbed. So, again that is very similar to condensation. In fact, in this particular case, the surface of glass being coated with water vapor is condensation itself. Am I clear with that? Anyone has any kind of confusion? Is this clear? Okay. So that's what we have as multi-layered. Physical adsorption is multi-layered. And further, in case of physical adsorption, the amount of energy that is involved is much lower as compared to bond energies. So if that particular energy is provided, the physical adsorption is easily reversed. I'm again going to tell you, in case of physical adsorption, the energy which is being evolved or energy change which is taking place is much lower than the bond energy. Since it is much lower than the bond energy, what we find is that if this particular energy is provided, the reaction is reversed, the adsorption is reversed. So physical adsorption is reversible in nature. Multi-layered, reversible. Any kind of confusions here? Snehal Patel, adhesion is a kind of adsorption only. Adhesion is on the surface. Okay? Adhesion is joining together. So why do we bother about it? Now let's get along with something called the chemical adsorption or chemisorption. Chemical adsorption is because of an actual chemical reaction taking place between adsorbent and adsorbate. The chemical nature is transformed. Something like when we have aluminium and we have gas, oxygen being adsorbed on aluminium. Oxygen actually reacts with aluminium to form aluminium oxide on the surface of aluminium, and this is what we have as chemical adsorption. Chemical adsorption is an actual chemical reaction. Now, since this is an actual chemical reaction, this actual chemical reaction would require an activation energy. Since it requires an activation energy, initially when you increase the temperature, the chemical adsorption is actually going to increase with increase in temperature. While if you keep on decreasing the temperature, you might not be able to provide the activation energy, and because of that, the chemical adsorption is going to decrease with decrease in temperature. So, since actual chemical reaction, activation energy is required. Okay, activation energy is required. And with that, we can say it initially increases with increase in temperature. So it initially increases with increase in temperature. Ananya, if you are able to understand the theory, then in that case, why don't you immediately solve the questions? Once you solve the question, you will be able to understand the theory as well as the concept, as well as numericals, as well as equation. The entire thing is about solving the questions. Most of the times we talk about solving the understanding the theory without solving the questions. Is that clear? Okay. Yes, Akash, the speed of chemisorption obviously is going to depend on the temperature, because the chemical reaction speed, that is reaction kinetics, it is going to be dependent on temperature. Quite obviously, if we have a high temperature aluminium in presence of oxygen, the oxide layer on aluminium will be formed faster. So the chemical adsorption is actually increased at an elevated temperature, but we are not talking about the elevated temperature to the temperature of 1000 degrees. We are going to talk about initial increase in temperature. Fine, Akash? Is that statement absolutely clear? So now initially it increases with increase in temperature, and then since the energy change is to the tune of the normal chemical reaction, so here we have large energy change. Now this energy change is similar to the energy of the bond energies in the adsorbent itself. If you provide that particular energy to the system, then in that case not only the adsorbent and adsorbate bond may break, it is the bonds between the particles of adsorbent that might break. For example, if we have aluminium surface and on that surface we create a coating of aluminium oxide and we increase the temperature, I believe you all know that aluminium oxide has a higher melting point than aluminium itself. So aluminium oxide is not going to decompose, although that aluminium on the surface of which the adsorption has taken place, that is going to melt. So that makes chemical adsorption irreversible. Most of the times you would have heard that the chemical adsorption is irreversible, but nobody would have told you the reason why chemical adsorption is irreversible. Chemical adsorption is irreversible because the energy change required to desorb the chemical adsorption is more than the energy required to melt or decompose the adsorbent itself. So the adsorbent decomposes even before the desorption takes place. Is this clear? Fine. So that is why chemical adsorption is irreversible. And most important, the chemical adsorption can be only single layered. Chemical adsorption cannot be multi-layered. Only single layered. Chemical adsorption is not multi-layered, and the simple reason is there. Once we have the surface on which the reaction has taken place, the surface is not of the adsorbent, it is something else. Like aluminium surface is there on which the oxygen has reacted. Now the surface becomes aluminium oxide. Any further adsorption of oxygen is not going to create any further aluminium oxide. Oxygen can be adsorbed on the surface of aluminium oxide, but that will be physical adsorption and not chemical adsorption. So chemical adsorption can only be single layered, adsorption can be multi-layered. The first layer could be chemical adsorption and the other layers could be physical adsorption. Clear? Whoever has not liked till now, please go ahead and like it. So that is what we have as the physical and chemical adsorption. The chemical adsorption is actually going to take place with the reaction. So when we talk about the chemical adsorption, the chemical bonds may be covalent or ionic, and generally chemical adsorption occurs at a high temperature and it's monolayered adsorption. I have already told you high temperature because we require the activation energy. So activation energy is necessary for the chemical adsorption. So we have already talked about the comparison, but let's have the comparison one to one. So when we talk about the property, we talk about the nature of forces. In case of physisorption, these are weak forces, that is van der Waals forces. In case of chemisorption, the forces are extremely strong, which are covalent or ionic bonds. Here we talk about specific. Now please remember, when we talk about the physisorption and chemisorption, both depend on nature of the adsorbent and adsorbate. They both depend on the nature. But when we talk about the physical adsorption, this depends on the physical nature. When we talk about the physical nature, we are talking about the melting point, we are talking about the boiling point, we are going to talk about the surface area, we are going to talk about the ease of condensation. That is what we are talking about when we are talking about the physics option. But when we talk about the chemies option, we are talking about the chemical nature. Here we are not talking about what is the melting point or the boiling point. Here we are talking about what is the reactivity. When we talk about the physics option, it does not distinguish between noble gases and the normal gases. Nitrogen is also going to be adsorbed in the same manner as argon would be adsorbed. But as we talk about the chemies option, then nitrogen might be able to react, but argon won't be able to react. So the chemies option is able to distinguish between the noble gases and the normal gases, but physics option is not able to. Physics option is simply dependent on the surface area. The gas which has a larger surface area, which is going to be easily condensed, it's going to be easily adsorbed. Yes, Ananya. So weightage of this chapter is 4 marks. So 4 marks, don't you think the 4 marks are worth 4 hours? I would say that you can consider each mark to be worth at least 1 hour. And if you consider that each mark is going to be worth 1 hour, it's going to be 720 marks are worth 720 hours. And they would say that chemistry is worth 180 hours. So we are going to complete the entire course in 180 hours, and you are going to spend 180 hours more on revision. So each subject is going to be 360 hours. Got it? So it's going to be actually 1440 hours in 1 year that you are going to spend to clear your entrance examination. We have 300 days. So 300 days would mean 1 hour 15. Let's see. It's 5 hours a day, isn't it? That much is doable. You don't have any time to waste. And you need to do the chapter with me thoroughly, because I don't want, or even you don't like to do this chapter once again. Clear? So that's what we have. So that is why I'm saying that you need to have the NCERT book along with it. So when we talk about the reversibility, physics option is reversible. We have already talked about why it is reversible, and while the chemies option is irreversible, and we know why it is irreversible. Clear? Now when you talk about the chemical, the temperature at which adsorption is more pronounced. So temperature dependence. This option is favored by low temperature, while chemies option initially increases with increase. Okay, so here with increase in temperature this one decreases, with increase in temperature this one increases. So here it's the energy change. In physics option the energy change is low, in chemies option the energy change is high. When we talk about the graphs, here we are talking about isobars of adsorption. Isobars of the adsorption means constant pressure. So here we talk about the graph. To talk about physisorption, here we have x by m. Now what does x by m mean? X by m means amount of adsorbate per unit mass of adsorbent. So that's what we have as x by m. Now please understand that we are considering that the nature of the adsorbent is not changing with the amount. The particle size remains the same or average remains the same, so that there is not a huge increase in the surface area or huge decrease in the surface area as the mass increases. So we are considering that as the mass is increasing, the surface area is increasing proportionally. So what we are considering, it is not actually m. It is actually the surface area that is going to affect the rate of the adsorption. So we are considering the surface area is directly proportional to mass. We are not changing the nature of the adsorbent. Yes, adsorption is used in Froth flotation method. Clear? We have already done only 1 hour as yet. We do have lot many hours. And I hope that today we would be able to finish off with this entire chapter, and I don't think so it is going to take more than 3 hours. Let us see. If it requires more than 3 hours, maybe half an hour more, that can be arranged right now. So here what we have is the surface area is proportional to the mass, and that's what we have here. So we have x by m, and when we talk about the physical adsorption, the graph actually goes, and here we are having the temperature. It does not make a difference whether you talk about the temperature in degrees Celsius or Kelvin, because the gap is the same. Even if you talk about the Fahrenheit, the graph is not going to change its nature. The graph would go simply like this. With increase in temperature, the physisorption is going to drastically decrease. With decrease in temperature, the physisorption is going to increase, because physisorption does not require any activation energy, and that is why it is going to be increased with decrease in temperature. Okay. So, and when we talk about the chemisorption, talking about the chemisorption, again it's x by m, and again it is temperature, and here we talk about chemisorption. Now here you need to understand that this question can be there in examination as well. NCERT said that it is going to increase with increase in temperature. The graph actually goes like this. The graph actually goes like this. Initial increase. Now this initial increase is because of the availability of the activation energy, which increases the rate of the reaction, and since chemical adsorption is a chemical reaction taking place, that is why it increases with increase in temperature. Doesn't make a difference, Ananya. Although I would myself prefer the temperature to be given in Kelvin, even if it is given in degrees Celsius, it does not make a difference for this particular graph. Okay. But as we all know that in chemistry we are going to use the temperature only in Kelvin. So this is what we have as the graphs of the physical and chemical adsorption and the difference between them. Okay. Then physisorption is multi-layered, whereas chemisorption is a single layered adsorption. Energy of activation, we have physisorption, there is no energy of activation. In chemisorption there is energy of activation. Rate, it all depends what kind of temperature we have. Okay. So all these things we have already discussed. Which is not correct regarding the adsorption of a gas on the surface of the solid? Should we consider it a physical adsorption? Which is correct, and which would be correct for the physical as well as chemical adsorption? You can just give me the answer. Which of these would be the correct for physical and chemical adsorption? There are 13 students watching. We have got 24 likes. Whoever has not liked as yet, quickly like it and subscribe to the channel NEET Elixir, Unacademy NEET Elixir channel. And also subscribe to my own page, that is unacademy.com/Anoop VASHISHTHA. Give me the answer. Which one would be the correct option? It's not necessarily reversible for all cases. Adsorption is more for some specific substance. That is true. And enthalpy and entropy change is negative. That's one true. Well, this also could not be true for some specific substance. Not specific, that is for only the chemical adsorption. But this particular phenomenon is valid for even the physical adsorption and the chemical adsorption. This is in general for adsorption. Option nahi dikh raha? Why is the option not visible? Okay, I was standing in front of the option. Now I am not. B maybe, B is there. Okay, so that's what we have as the option. Can both adsorption process occur simultaneously? And here we are talking about the chemisorption and physisorption taking place simultaneously. The answer to this particular question is yes. The physical and chemical adsorption can take place simultaneously. Physisorption at low temperature may pass into chemisorption at the temperature is increased. Okay. As the temperature increases, the low temperature physisorption can become a high temperature chemisorption. Clear? Now let's get along with the adsorption isotherm. The adsorption isotherm. Now this is what we have as the Freundlich adsorption isotherm. This gives us the variation in the amount of gas adsorbed by the adsorbent with pressure. That how the adsorption changes with pressure. Now, when we talk about this Freundlich adsorption isotherm, it is an experimental curve. Is that clear? Where are the students gone? Yes, we are going to talk about this particular equation. At a constant temperature, a variation amount of gas adsorbed by the adsorbent with pressure can be expressed by a curve termed as adsorption isotherm. Clear? Now, what exactly would be the adsorption isotherm? Here is the adsorption isotherm. This is again x by m, this is the pressure. As we increase the pressure, initially the adsorption keeps on increasing, and after a certain pressure, the adsorption becomes a constant. Here we can talk about the three regions, 1, 2 and 3. In this particular region, x by m is directly proportional to P. Here x by m becomes equal to a constant. While in this region, x by m is proportional to P raised to power 1 by n. Now, x by m proportional to P raised to power 1 by n, n is equal to 1 and goes up to infinity. That is, the adsorption is proportional to the decreasing powers of P. So, x by m is proportional to decreasing powers of P. So that is the meaning of the reaction. If anybody is disturbing you, rather than telling that the person is spamming, you simply block that person. Is it clear? So there was a person who was spamming at this moment. I just simply blocked the person. Okay. Snehal, at this moment we can't have the lunch time. We can just have the session time. We can finish off this particular topic and then we can think over with the lunch. Okay. So this is what we get as the adsorption. Now this is the Freundlich adsorption isotherm. Here what we can say is x by m is proportional to P raised to power 1 by n. Now to make proportionality as equality, we need a constant, so we make it x by m is equal to k P raised to power 1 by n. For a particular value of n, that is a particular point on the curve, you can consider a specific value of n and then you can take the log. Log x by m is equal to log k plus 1 by n log p. Clear? So this is what we have as an equation for a specific value of n and specific point on the curve. Now if you want to make a graph of this also can be converted into a graph, and here we have log x by m and here we can have log p. The graph is going to be a straight line but not passing through the origin, it's going to pass through some other point. This is what we have as an intercept. Now this intercept would turn out to be log k and the slope is going to be 1 by n. Is this clear? Fine. So this is what we have as the Freundlich adsorption isotherm. This is how we express the relation. Vijaya, I am at Unacademy. Unacademy NEET Elixir. K and N are constants. X is mass of the gas adsorbed, M is the mass of the adsorbent, and it depends on the nature of the gas and the adsorbent. Okay, it keeps on changing for the different temperatures. A plot of log x by m versus log p for the adsorption of a gas on the solid gives a straight line with the slope equal to, I have just told you the slope. What is the slope? Give me the answer. What will be the answer here? The slope is log k. Slope. This is the slope. Ananya, what happens? You are not giving the proper attention to whatever I am telling. Slope is 1 by n. Log k is the intercept. Yes, Radhika, you are absolutely right. Log k is the intercept. Is this clear? So that's what we have as the Freundlich adsorption isotherms. And now we are going to begin over with the catalysts. Anybody has to ask anything? So let's talk about the catalyst. Many times students ask me what could be the best example of a catalyst. How could we imagine what a catalyst does? So let me make it very clear what a catalyst does. Okay. Let's say we have to reach a specific platform. This is the platform. Okay. Now to reach that platform we could have many ways. A person could simply jump over like this. That could be one way, and there could be so many multiple ways. We could have a lift, we could have a person hanging from the helicopter through a thread or a rope, and then a very logical, very simple way of reaching the top would be the staircase. The stairs. Okay, the stairs would allow us to reach the particular place. Now, first of all, one thing more. The property of stairs. Okay, what are the properties of stairs? First thing, do not provide or consume energy. The stairs in themselves do not provide or consume the energy. First thing. Second, break the energy required for entire process into small parts by giving an alternate path. By giving an alternate path. Is this clear? Okay. Third, it forms an intermediate ठीक है, and is regenerated. Clear? And most important, the stairs not only help you in moving up, they also help you in moving down. Fourth, facilitate process in both directions. Is this clear? Purnesh, x by m becomes a constant after a particular duration because the entire surface of the adsorbent is consumed. Ananya, it's not the time for lunch. Okay, so that's why I did not have my lunch. I had my breakfast. I'm going to have my lunch after the session. Now, these are the properties of a staircase. What other properties can you think of? Whatever properties you can think of the staircase, the same would be the property for the catalyst. So a staircase is actually a catalyst. Anything you would like to ask here? So just remember the catalysts are staircase. Any confusions with that? There are so many catalysts. There are so many catalysts working in a different manner. And here we are going to talk about the different catalysts. The catalysts are divided into many categories, but mostly we talk about the two categories, that is homogeneous and heterogeneous catalysts. So let's get along with the type of catalysts. We can talk about the catalysts on the basis of phases. That is, we can have homogeneous catalysts, that is, which are the catalysts which are in the same phase as the reactant and the product. Those are what we call as the homogeneous catalysts. And then we could have the heterogeneous catalysts, which are having a different phase. That is, maybe the reactant and products are in the gaseous phase while the catalyst is in the solid phase. Okay, or the reactant and product are in a solution and catalyst again is in a solid phase. So that is what we have as the heterogeneous catalysts. Okay. But we need to understand, as far as NCERT is concerned, NCERT talks only about the positive catalyst. The negative catalysts are more often not termed as negative catalysts but inhibitors. Okay. So negative catalysts are more often termed as inhibitors. Okay, fine. So let's talk about the catalysts, the types of catalysts on the based on phases, the homogeneous and the heterogeneous catalysts. When the catalysts and the reactants and the products are in the same phase, the process is called homogeneous catalysis. The catalyst is called the homogeneous catalyst, and there are so many examples of that form. Like we have the process which we call as hydrolysis of ester in acidic medium. In case of hydrolysis of ester in the acidic medium, the H plus becomes the catalyst, the ester, the water, the product, that is alcohol, the carboxylic acid, and the catalyst, which is H plus, they present in the same phase, that is, they are present in the same aqueous solution. Yes, Ananya, you are perfectly right. Hydrolysis of methyl acetate, it's a homogeneous catalysis reaction. In the same manner, when we talk about the oxidation of sulfur dioxide, and this is what we call as the lead chamber process of preparation of sulfuric acid. This is what we have as the lead chamber process of preparation of sulfuric acid. So this is what we have as the oxidation of sulfur dioxide, and this is a homogeneous catalyst because all the reactant, product and the catalyst, they are in the gaseous process, gaseous phase. Is this clear? So that is what we have as the lead chamber process. Then we could have heterogeneous catalyst. Heterogeneous catalyst in most often is going to be in the solid phase. So heterogeneous catalysis is something to do with adsorption. So catalyst and the reactants are in different phases. The process is the heterogeneous catalyst. The catalyst is the heterogeneous catalyst, and most often catalyst is in solid phase. Well, I fail to realize when the catalyst is going to be in the gaseous or the liquid phase. When we talk about heterogeneous catalyst, we are actually talking about the solid phase catalyst only. Clear? So many examples of it. Decomposition of hydrogen peroxide, using MnO2 as a catalyst, and even yeast as a catalyst. Hydrogen peroxide can be decomposed using yeast as a catalyst, and many other cases. Then the Haber's process of manufacture of ammonia, in which we are using iron molybdenum catalyst. Iron is a catalyst, molybdenum is a promoter. Nowadays we are using an oxide catalyst, in which iron oxide is a catalyst, and so many other promoters. So this is what we have as the Haber's process. So again, the reactant and product are gases, while the catalyst is a solid. Here the reactant and the product, one of the product is gas, another product is a liquid, reactant is a liquid, while the catalyst is a solid. So this is again a heterogeneous catalysis. Clear? The positive catalysts are the normal catalysts that we have, and the negative catalysts are what we call as the inhibitors. The positive catalysts increase the reaction rate, they decrease the activation energy. In fact, they form a reactive intermediate, while the inhibitor actually forms a more stable intermediate, which is difficult to react, and it's going to slow down the speed of the reaction. So we are going to even talk about the inhibitor mechanism. So on the basis of the impact on the rate of the reaction, we have negative catalysts, which are called inhibitors, and inhibitors are going to decrease the rate of the reaction. So that's what we have, the reactants, products, and it actually increases the activation energy. Why do they increase the activation energy? They form intermediates which are more stable than reactants. So that is why they require even a higher activation energy to react. Okay. So that's what we have as homogeneous and heterogeneous catalysis. And then we have some other important terms: promoters and activators. Promoters, activators, and poisons, these are the substances which actually act on the catalyst rather than the reactant. Inhibitors and catalysts, they act on the reactants, while promoters and poisons, they act on the catalyst. They increase or decrease the activity of the catalyst. So that is what we have as the promoter. Priyanshu, I have just given your answer. Inhibitor acts on the reactant. It stabilizes the reactant, while the poison, it acts on a catalyst and it decreases its activation. Clear? Purnesh, this graph is a normal graph. This is a common graph. It's going to be everywhere. What are promoters? Which increase the activity of the catalyst. I'll tell you one thing. Let us say I am a teacher. I am teaching you the various things. Now there are many aids which I am able to use, like I am able to use YouTube, I am able to use this smart board, I am able to use the computer. Now these all factors, they enhance my capacity. So these are promoters, while I am the catalyst. Then there could be certain poisons. Maybe the electricity is not working, I am feeling lethargic, I have not had a good food, or somebody is disturbing me. Now that person is a poison. It is reducing my activity, and so that I am not able to do the work which I am intended to do. And that becomes the poison and the inhibitors. The poison or the depressants, anti-catalysis. Is this clear? So that's what we have as the terms. We have promoters, we have activators, we have poisons, and we have anti-catalysts. So substances that are not catalysts themselves, but their presence can increase the catalytic activity of a catalyst. They are what we call as promoters. Clear? Like nickel catalyst, we are using Cu promoter. Fe catalyst, we are using molybdenum promoter. So these are enhancing the capacity of a catalyst. Is this clear? So here we suggest that molybdenum actually helps in increasing the working of nickel. Then poisons are there, and the very, very, very famous poison, cyanide. I believe you know how the cyanide works. The cyanide actually works on an enzyme, that is cytochrome oxidase C, in our body and blocks it. So it is a poison because it acts on a catalyst, that is an enzyme. Snehal, what are you asking? Which book is good for practicing question? Anyone? The best book for practicing question would be NCERT Exemplar book. In addition to that, you can buy any of the previous year question book and any other practice book. But I would sincerely suggest that you do not go to a book which is having a very, very difficult question. Precisely speaking, do not go for the books which are claiming to be giving you the question related to IIT Advanced. Please don't do that, because that's not required by you. At the most, you can actually do the IIT mains question book, which have already been asked in the examination. That would be more than sufficient. But sincerely speaking, the previous year question books of NEET examination, the AIMS examination, or DPMT, CPMT, old question book, they also can work. Is it okay? Just do not go for any book which claims to give you very difficult or very nice question. Don't go for those. Okay. The substance processes related to catalysis are promoters, activators, poisons, activate catalysts. We have just already talked about it. Where are they? Why has it gone back? Okay. Poisoning is due to preferential adsorption of poison on the surface of the catalyst, like carbon monoxide on the surface of iron. It is going to combine, it's going to form a complex with iron and not allow the iron to form the catalyst. It is not able to catalyze any further. So the poisons actually block the surface of the catalyst and prevent it from doing any catalyzing activity. Is this clear? So that is how the poisons work. And those who have already joined, we have just joined, could you just like the session? Okay. So here, and even CO, it is not CO, it is CO. This is carbon monoxide, which acts as a poison. Now, hydrogen sulfide acts as a poison because it forms a layer of iron sulfide on the surface, which prevents any further reaction. Clear? Now, this is what we call as the Lindlar's catalyst. BSO4 is actually the base on which the catalyst is spread. So it is poisoned palladium catalyst in Rosenmund's reduction. Clear? And in contact process, initially it was platinum which was used, but arsenic oxide present in sulfur dioxide used to poison the platinum catalyst, and that is why V2O5 is nowadays used in the contact process. Vanadium pentoxide is used. Okay, what does the catalyst do? A catalyst. What does it do? Changes the equilibrium constant, it lowers the activation energy, it increases the forward and the backward reaction at different speeds. It follows the same mechanism for the reaction. What is the truth about the catalyst? Could you just give me the answer? It only lowers the activation energy, rest of the things remain the same. The heterogeneous catalysts are explained using the adsorption theory. So we are going to talk about the adsorption theory of heterogeneous catalysis. Clear? We talk about this modern adsorption theory. What is the adsorption theory? The reactant is adsorbed onto the surface of the catalyst, which decreases the bond strength between the particles or the atoms of the reactant, which then breaks, the bond breaks and another bond is formed. Clear? So catalyst forms temporary bonds with the reactant, resulting in an intermediate complex. This exists for a short time and decomposes to yield the products. So here we have the mechanism. The surface of the catalyst, like the inner part of the bulk, has free vacancies. Again, the same thing, that is adsorption. The adsorption is taking place. Clear? The surface of the catalyst, like the inner part of the bulk, has free vacancies that provide the seat for the chemical forces of attraction. The reaction is able to take place. So here is the surface of the catalyst. The reactants, they attach to the surface of the catalyst. The reaction takes place. The bonds are formed and the product is formed. Now here there is a part called desorption. The desorption plays a very important role in the heterogeneous catalysis, because desorption is responsible for the creation of the recreation of the surface of the catalyst. Is this clear? So that is what we have as the hydrogenation. According to the adsorption theory of catalysis, the speed of reaction increases because, could you give me the answer? Which of the following kinds of catalysis can be explained by the adsorption theory? Heterogeneous catalysis. What are the important features of the solid catalysts? The activity, the selectivity, and it's all given in the NCERT. The activity of a catalyst depends on the strength of the chemisorption to a large extent. More is the chemisorption, more is the tendency to catalyze. Reactant must get adsorbed reasonably strongly onto the cut to become active. Adsorption should not be as strong that it becomes irreversible. Okay. They are quite selective, because if you change the catalyst, the product also changes, and NCERT has given it that many of the reactant, once you talk about the change in the catalyst, the product also becomes different. Okay. So on the nickel surface you get methane with carbon and oxygen, hydrogen, carbon monoxide and hydrogen, and if you have copper surface you get formaldehyde. If you have the ZNO surface you get methanol. So here if you change the catalyst you are going to change the product. Is this clear? Yes, Ananya, you need to read the NCERT. After this lecture, you will be able to understand the entire NCERT up till the catalysis part, or at least. Then we have something called zeolites. Zeolites are called shape selective catalyst. These are responsible for the size. Zeolites are good shape selective catalysts because of their honeycomb like structure. They have a perfect entry and exit. These are the zeolites. Okay. So they have perfect entry and exit. Only a specific shape molecule can enter them and shape molecule can exit them. So those are zeolites. Zeolites are used in the petroleum industry. ZSM5 is able to convert the alcohol direct into a gasoline. Hydrocarbon mixture. And here comes the enzyme catalysis. I believe, Priyanshu, no, we don't have gold number given in NCERT and it's not being asked anywhere. Yes, Ananya, we have only the chemistry class today. Yesterday also we had only chemistry class, isn't it? Don't worry about it. You are going to have biology class. Maybe tomorrow you are going to have 2 biology classes. Okay. Enzyme catalyst, you would be very much aware of it. These are actually protein molecules of high molecular mass and form colloidal solution in water. So many reactions are taking place using the enzyme catalysis. And they are termed as biochemical reactions. This time in 2023, we had a question regarding the entire enzyme catalysis. Okay. Inversion of cane sugar is taking place in the presence of other enzymes, the zymase. So here we talk about the lock and key mechanism of enzyme catalysis. Activated complex. There are specific characteristics of enzyme catalysis. Rimi, what exactly you want to know? Enzyme catalysis is extremely efficient. One molecule of an enzyme may transform 1 million molecules of the reactant per minute. Well, Ananya, That's a good information, but that's not going to be required in your NEET examination, because in chemistry we do not talk about these informations. Okay, they are highly specific in nature. Each enzyme is specific for a given reaction. One enzyme cannot catalyze more than one reaction. They react only certain reaction. They are highly reactive under the optimum temperature condition. The rate of an enzyme reaction becomes maximum at a definite temperature. So optimum temperature are important, optimum pH is important. So that's what we require for a catalyst. They also require the coenzymes and activators, and poisons also work on them. Inhibitors and poisons, they also work on the enzymes. Which one of the following statement is incorrect about enzymes? Could you give me the answer? What is activated complex? The complex which is formed due to the combination of the catalyst and the reactant. That is an activated complex through which the product is formed. It's an intermediate. This would be the correct answer, because enzymes are most reactive at the optimum temperature. There are some industrial catalytic reactions, Haber's process, the contact process. Now this is what we have as colloids, but we are going to do colloids in the next class. This time we are going to end it here. So here we have iconic mega sale that's working on. Maybe it's working at this moment or not. Ask it, Akash. What exactly you want to ask? हाँ बेटा, लास्ट वाले क्वेश्चन में you had to mark incorrect. At 3 p.m. you are having, so I just want to ask you that in third chapter, that is in periodic classification, of which are the correct steps rather than topics which I need to make focus upon more, as the chapter is more theoretical. What you need to do is just do the back questions by writing through them, and you will be able to cover up all the concepts which are required. Is this okay? So at 3 p.m. you have biology class with Dr. SACHIN KAPUR. At 4 p.m. you have the chemistry class with me every day. So you can go ahead and join with the Unacademy app. You can go ahead and download the Unacademy Learner app, and then you can select your goal and join with me. Okay. So this is what we have as NEET UG subscription. You can go along with Iconic Plus, and you can go along with Centers. Go ahead and join with me on unacademy.com/@AnoopVashishtha. This is my page on Unacademy. Clear? Follow me. We have got certain minutes for last 30 days. Join Unacademy NEET Elixir for the best live classes. Like, share and subscribe to the channel. Thank you. Today itself we are going to meet at 9 p.m. for the next class, and we are going to finish off with the colloids. So today itself we are going to have the class of colloids. Is that okay? We are going to finish this chapter today. Bye bye. Take care. We'll meet you in the evening today itself. Bye bye.